Hello everyone, in this case I want to deliver a presentation about multi-criteria decision analysis method for siting energy generation from municipal solid waste. This presentation is systematic review of my research team. Let me introduce myself. My name is Muhammad Tahir Kunanda. I'm from Department of Agriculture and Biosystem Engineering, Pajajaran University. The outline of this presentation, I will break down it into 5 terms. The first one is called municipal solid waste. Number 2 is issue explanation. Number 3, criteria, recommendation, and the last one is conclusion. Municipal solid waste is a type of solid waste generated from community, commercial, and agriculture operations. It figures kind of municipal solid waste, and this figure also it may include biodegradable waste, electrical and electronic waste, and composite waste such as clothing, hazardous waste, and medical waste. The total of MSW generations in each country has a increasing trend every year. I import this figure from humicedu.com. Municipal solid waste has shown an increasing trend in the last decade worldwide, mostly due to higher population size, urbanization, and changing lifestyle. So the government have to take a decision how to reuse waste to energy, from waste and then waste collection, the next step, and discovering to plant for processing, and the waste process and the end product of waste can be used for fuel, gas, electricity, etc. But one of the critical steps in establishing an energy generation from municipal solid waste is choosing a suitable location by considering various factors. So we don't know where the suitable location for energy generation. Maybe here, here, or here. It is a complex task for us where we choose the suitable site for energy generation. Maybe the site selected must be ideal for conditions before and after closure. If we talk about the siting energy generations, we have to consider numerous factors from safety, economic, environmental, technical, and social. We have to consider it because we want to minimize the conflict of interest, maybe the technical problem and negative to environment. So in this case, we need a lot of method where to choose the suitable site for energy generation. The well-known method is MCDA, multi-criteria decision analysis. In multi-criteria decision analysis, there are a lot of approach like a fuzzy, AHP, analytical hierarchy process, MCDM, TOPSIS, etc. So the issue are researchers are often stuck in determining the appropriate method to apply in their case because various MCDM methods have advantages and disadvantages, and some researchers are often stuck in determining. So we want to uncover this issue. The next issue is knowledge and characteristic of various MCDA methods are still lacking in deciding the suitable energy generation. So we want to solve two kind issue. Of course, the objective of this study was to present a systematic review of MCDA methods for siting energy generation from municipal solid waste. So the next sessions we talk about the results of systematic review. Based on the analysis, we review about 5 aspects: environmental, economic, social, safety, and technical. Every aspect has a criteria. For example, in environmental, there are climate, distance from agricultural area, etc. The study has collected 32 criteria from the literature for siting energy generation. Based on the analysis, the criteria of flooding area, distance from fault, social acceptability, and job creations, I colored it with a red color, have not been utilized for locating energy generations. So this is good news for us, where we can use this criteria for our research future. About the various MCDA methods, we analyze 4 popular methods in MCDA. Number 1 is WLC, weight linear combination, analytical hierarchy process, analytical network process, and the last one is fuzzy. Some of the most popular methods are summarized below. So in the MCDA method, we have 4 methods. We want to report about the software package. We break down it into 2 types, free and paid. Based on this report, the free software is dominated among others. So the previous software is free, supervision, etc. So if we want to utilize this software, we can. In this section, we talk about advantages and disadvantages in every methods. VLC, the advantages is simple, but disadvantages, it tends to be ad hoc procedure, incomplete, incorrect decision problem, and also VLC is less accurate. So before we make a decision about where the best MCDA method for our research, we can refer to these informations. A and P have advantages, for example, providing reliable and fault-tolerant results, but the disadvantages is complexity in prioritization process. So based on the analysis, we want to recommend various methods that we can use. So each MCDA method shows advantages and disadvantages in its application. The MCDA method selection can affect the final result of pi-wise comparison as well. Therefore, based on the time, data, complexity, and resource requirements, we recommend the best to the less good performance for MCDA method. So the NAP, this is the best one based on the time, data, complexity, and resource requirement. This is a good one, and this is less good, because the ALC has these advantages like less accurate for decision. So if you want to utilize the MCDA method, you can use ANP, this is the best one, AHP, until the less good one. So the conclusion of these presentations, I will withdraw it into two terms. One is the criteria of floating area, distance from float, and job creation are still not used. So this gap provides instructions to the scientists as an opportunity as well as a novelty for future research. So if you want to make a proposal about the energy generation site selection, you have to include these factors to the analysis. And the last one is the MCDA method with the best to the least good performance. Sequentially are analytical network process, analytical hierarchy process, fuzzy, and the last one is like linear combination. So this study work was funded by the Ministry of Research, Technology and Higher Education. We thanks a lot for this institution for funding. Okay, thank you. Thank you so much for your attention. See you next time.